Alright, a little X-Files action. Today we're solving rational equations and inequalities. And today is simply solving rational equations. This is the procedure. There are obviously other procedures to do this, but this is one way. So we make all the terms fractions. When you subtract, you know what you have to do. Finding a common denominator is extremely important. And then from there, things become interesting. So read them over, and this is what we're going to be doing. Okay, this is our first example. So if you look at the steps as we go, might make it easier for you. So the first step is make all terms fractions. So now they're all fractions. Great. Give each one of them a common denominator. So all three have to have a common denominator. So I like to just make note of what it is so that I know what I have to make each denominator. So my common denominator here is going to be x, because only x is there. Okay? We went through how to do that in adding and subtracting. So each one of these needs to be added in. Needs to have an x as a common denominator. So I multiply the two that don't have it by x on the top and the bottom. Now what winds up happening is you get x squared over x minus 14 over x equals 5x over x. All the denominators are the same. Now this only works in an equation, okay? So make sure you know this is an equation when you're doing it. You cross out the denominators, and you're left with x squared minus 14 equals 5x. And you simply solve that equation. That's it. So you know how to solve this equation. It is a quadratic. So you set everything equal to one side, where the x squared is positive. So I'm going to subtract my 5x. X squared minus 5x minus 14 equals 0. Then we factor. Whatever method you feel most comfortable with. Two numbers that multiply to negative 14 and add to negative 5 are negative 7 and 2. Solve each one of these. So x is negative 7 and x is, positive 7, and x is negative 2. Then we have to go back. Final step. These are our two answers, 7 and negative 2. And then you come back and you say, okay, if I put a 7 in the denominator here, then that denominator is 7. Okay? If I put a 2 or a negative 2, then the denominator is negative 2. Our goal is an extraneous root is where the denominator is 0. And here that doesn't happen, so we're good. The answer is, or the answers are 7 and negative 2. Okay? Same deal for this one. Just processes the same, different examples. Make everything a fraction. Now, I like to make that 2 negative. I don't know, it's just my thing. If you don't have to, you don't have to, but be careful you don't lose your negatives. We need to find a common denominator. Now, again, we did this with adding and subtracting. This is x. This is x plus 1. They have no factors in common. So x times x plus 1 is your common denominator. So you multiply by what's missing. So this one has the x plus 1. It doesn't have the x. This one has the x. It doesn't have the x plus 1. And this one doesn't have any of it. Okay? Now all my denominators are the same, so at this moment I'm just going to go bam, just so I don't have to deal with that. And now we just do the multiplication. So here, or I'll write it out. So it's 3 times x plus 1, so it's 3x plus 3. This is negative 2x. Now these two are multiplied together, so we take negative 2x and we multiply it times the x. So it's negative 2x squared. And then it's negative 2x times, maybe it's be a good idea for me to actually show that. So that negative 2x, when we multiply that together, is negative 2x. And then we have to multiply it times the x plus 1, Okay, and then the top is down over here is negative 2x squared. So this is the more confusing part of that problem. You just have to remember you take the negative and the negative, the 2, and the x, and distribute that through. Okay, just to be clear on that, I hope. Okay, shout out if I'm making a mistake here. All right. Combine like terms, this is, oh, I see that this is exactly the same as this. So if I were to combine these two by changing them over, these would cancel themselves out. Nice, I'm left with a straight linear. These two are like terms, so that's just 1x or x. 3 is here. There's no like terms for the 3, and then it's 0. So I have to solve for x, so subtract my 3, and x is negative 3. Go back, check to make sure if I put I don't know if I can erase still. No. If I put in my common denominator, so the denominator is this. If I put negative 3 in that denominator, okay, what would I get? So it's negative 2 times a negative 3, so it's a positive 6. 6 is not equal to 0, so we're good. Negative 3 is the answer. Done. Okay, other side. All right. Now this one looks complicated, and it does have a typo, so let me do a quick, we gotta fix this problem, because when I wrote it, I kind of messed it up. This one should be x minus 1 and 3 minus x. Okay, so the second fraction has a mistake. And then we solve. Okay, so if you look at this one, hopefully you notice that these are all opposite factors. Okay? Not all, but they are opposite factors. So our common denominator here is x minus 3. Now you could make it 3 minus x also. It's up to you. But I'm just going to do x minus 3 here. Okay, so they're all fractions. I like to keep change. So I'm going to do this. Keep this the same, change this to addition, and change the sign of everything in the top. Okay, so now if I want to make x minus 3 my denominator, I have to multiply the top and the bottom of this one by negative 1, and the top and the bottom of this one by negative 1. So when I do that, I get x over x minus 3 plus, so this negative, I'm changing it back basically, is positive x and a negative 1 over x minus 3. And this side is just 5 over x minus 3. Denominators get canceled out, and we have a nice simple equation. X plus x minus 1 equals 5. Solve it. We get 2x minus 1 equals 5. Add 1. 2x equals 6. Divide by 2, and x is 3. Alrighty. So if x is 3, we go back. We say if I put 3 into this denominator right here, it will be 3 minus 3, which is 0. And this is bad. We can't have a denominator be 0. So therefore, that's an extraneous root. We reject that. And we simply write no solution. I know all that work for no solution, but you wouldn't have known unless you did the work. All right, next one. This one looks like it might get complicated. However, it's all right. So for this one, I should make it a little bigger. You'll see if it's a proportion. You have a fraction equal to a fraction. Whenever you have a fraction equal to a fraction, you can simply cross multiply to solve. This is the only time you can cross multiply, is when you have two fractions equal to each other. Okay? Not through any other symbol but an equal sign. So an equal sign is it for cross multiplying. Okay, so let's do it. 3x plus 2 times x plus 5 equals, so one side, the product of the means, is equal to the product of the extremes. I think this one's the means, but whatever. So x minus 1, 3x plus 10. And then we solve. So you have to multiply. If you like the box method, do that. If you don't, don't. Okay, but in the end, you should get 3x squared plus 10x. Nope, hold on, I got this. Erase. I'm going to do it all at once. I can't do things that fast. Okay, so plus 15x plus 2x plus 10 equals 3x squared plus 10x minus 3x minus 10. I look here, right away I see these are the same factors on opposite sides, so when I subtract them, they cancel themselves out. Combine your like terms. I have 17x plus 10 equals 7x minus 10. So I do this first, and I get 10x plus 10 equals negative 10. Solving this, I'm using a different color. Subtract 10 here, and I get 10x equals negative 20. Divide by 10, and x is negative 2. All right, we got to go back and check. Make sure that in the original, if I put a negative 2 in, I don't get a 0. So this denominator here I check. Remember, only denominators need to be checked. So it's negative 2. Oh. Negative 2. What the heck was the answer? Oh, minus 1. Okay, so that's negative 3. Negative 3 is not 0, so that's good. So then we do x plus 5. We plug a negative 2 into that, and that is negative 2 plus 5, which is 3. That isn't 0, again, so that's good. Woohoo! We have an answer for this one, and the answer is negative 2. Done. Have a nice day.